Hey guys, today we're walking through the hose heat system on the Boss machine. For a quick summary of this video, you can jump ahead to the time step in the description below. We are working with electricity today, so take precautions, be extra aware when power is live. If you don't feel comfortable performing these tests, consult a trained electrician or give us a call here at the shop, 888-640-BOSS. Hope you guys find this video useful. The first thing that you want to do once you know or suspect that your hose is not heating is test the outgoing voltage from the machine itself. Once we've tested the outgoing voltage, if we determine the voltage is good from the machine side of things, then you know that you don't have to test anything else on the machine side of things. Your problem is going to be within the hose itself. To perform that test, you can test between the two red copper wires that are coming out the front of the machine. However, those are normally insulated and wrapped up in the scuff jacket and hard to get to. So usually it's actually easier if you want to take the lower access cover off the side of the machine and test the outgoing voltage there. Before you do so, it's important to go ahead and turn off the hose heat power going down to the bottom of the machine. To remove the lower access cover, you'll simply remove the front two screws on the front side of the machine and the rear two screws on the back side of the machine. So if you were to call in for a hose heat issue, the first thing we'd look to confirm is that your hose actually is not heating. And you can do that with this clamp style multimeter. Now, if you don't have a clamp style multimeter, it's okay. You can actually move on to the other tests and still figure out exactly what's happening with your hose. Or if you just are confident that it's not actually heating, you can skip this step and move forward. But we like to confirm that you actually have a hose heat issue and not a temperature sensing issue. Perhaps the purple wires come out at the end of gun end of the hose and it's not reading accurate temperature, it's reading more of an ambient temperature. That can make the controller appear as if your temperature is not rising when in reality your hose is actually still heating. Testing how many amps you're drawing will confirm that your hose is heating or that it's not heating well or it's not heating at all. So the first thing that we want to do is go ahead and turn our hose heat breaker on. And once it comes on, right now it's not set to call for heat, so it's important that you go ahead and set it to call for heat. Let's go ahead and press the asterisk in, and then you'll adjust the temperature. Let's go ahead and set it a good ways higher. That way we can make sure it stays calling for heat. So we'll set it right at 100. So you're going to know it's calling for heat because that green light on the controller is going to engage. At that point, we're going to take our multimeter, and this one for amps, there's an A with the little squiggly line, so you'll just turn that to that setting, and then you're going to clamp around either one of the red wires coming out the front of the machine go into your hose, the power leads. It doesn't matter which wire you clamp around, either one will work. And so we're going to clamp around, and you can see right here our amps are actually really high on this hose, and that's because I think it's actually a 1/4 inch hose. It's pretty much the max you would ever want it to be. Really, you don't want it to be over like 42, 43. It's at 45 amps, so this hose is heating very well. So right now I'm going to go ahead and turn this hose heat off so that it kills the power, and you can see we're not drawing any amps anymore. So let's say you did this test right here and your amps were perfect, like right then it was a little high, but we can tell the hose is for sure heating. At that point you would want to go check your TSU wire if your temperature was not rising on your controller and make sure that it hasn't pulled out the end of the hose and is reading that ambient temperature. But we'll assume that for right now your amps were not what they need to be. So let's just say your amps were a little lower than they need to be. You would want probably it to read around 35 to 40 would be kind of the sweet spot. But if it's less than 35, then what we're going to want to check is to make sure that you have the right voltage option hooked up from your transformer. You know, if you've added a section of hose recently, you might need to up your voltage option because that hose has more copper on it, more resistance. You're going to wind up needing more voltage output. So it could just be that you need to change a voltage option if you have low amps, or it could be due to the low incoming power on the machine. So at that point you'd want to check the incoming power, and we'll get into that in just a second. So if you're not drawing any amps at all, we still don't know whether it's a machine issue or whether it's a hose issue. It could be just a break in the circuit somewhere along the length of the hose, a loose connection, a broken spot to where the power is not making it all the way down and back. Or you could actually have an issue where the machine's not putting out any voltage, which could be related to a blown fuse or relay, or incoming power again if you don't have any incoming power. So we still don't know at this point. So the first thing we want to do is test the voltage coming out the front of the machine. And the reason we want to test the voltage output from the machine is if the voltage output is what it's supposed to be, then we can eliminate the machine as a potential issue. If your machine's putting out the voltage that's supposed to be putting out based on what option is hooked up from the transformer, then we know, okay, machine's working great and we can look in the hose. If it's not, then we know there's more tests we need to perform on the machine side of things. So the best way to test that is by using your multimeter to test for voltage AC. And you'll need to get the probes that plug into the bottom, and you'll need to adjust the multimeter to voltage AC. Some multimeters will say VAC, or they'll have this little V with a squiggly line. So once you have your probes connected, you can test the voltage output by testing at the end of these red leads that come out the front of the machine and connect to the hose. But most of the time, your splices that those are connected to are going to be taped up and secured in the hose. So really the easiest place to test those is off the back side of the fuse and the relay where they come from, which is down in the lower compartment. But you most likely want to go ahead and open up that lower compartment anyway to confirm what voltage option is hooked up from your transformer, so that you know how much voltage you should actually be getting out of the machine. So we'll go ahead and open up that lower access compartment where the hose heat components are, and the first thing you want to do is make sure that your hose heat is turned off. We've already turned ours off, but you want to turn that off, and then we'll go ahead and remove that lower cover. So to remove the lower cover, you can use a 5/16 nut driver or an impact, which I'm going to use here. And you'll just remove the 4 screws. There's 2 on the front and 2 on the back. All right, so once you have the screws out, the only other screw that you might have to take a look at, sometimes these 3-meter screws will dig into the top edge. On some chassis, depending on what the design was, that could be an issue, but on most of our new chassis, that's not anything that you have to remove. But afterwards, you just pull that cover straight out, and it'll reveal all the components, the hose heat components, that are in the lower portion of the machine. All right, the first thing you'll notice once we have the access cover off is obviously 3 main components, or 4, for your hose heat system: the transformer itself, the fuse holder and fuse, and the solid state relay. Now the first thing you want to identify is which voltage options are connected from your transformer to your fuse and relay, because that determines how much voltage you're getting out of your machine. So typically the 0 volt lead is always going to be going to your solid state relay unless for some reason it's been adjusted. The lead that's connected to your fuse holder will be determined by what length of hose you have. There's many different options. The ones that aren't in use or have wire nuts and tape on them. Typically every machine gets sent out with the 20 volt lead connected for a 50-foot hose. And that's just as a safety precaution. You don't want to have the 64 volt lead connected for a 200-foot hose if somebody's going to put 50 foot on the machine. So we go ahead and just set it for 50, and if you have a longer hose, you'll need to adjust that from 20 on up, and we'll put the chart in the video for the correct voltages for Boss hoses, the different lengths of Boss hose. Everything we refer to in this video will be the 20 volt lead, which you would use for a 50-foot hose. Now one thing to note, you always want to be cognizant of when you have your hose heat turned on. Right now we have it turned off, but when it is on, power will be live down here, so you want to be careful. There's 240 volts that come into the left side of your transformer. There's 2 white wires where the main power comes in, and then you have multiple options coming out, and the different combinations determines how much voltage comes out to your hose. Now you also want to be careful of these paper wraps. They have pretty sharp edges and they can cut your hand pretty easily, so just be careful when you're working down in there. Now, the first thing that we want to determine is the voltage output from our machine. So to test that, like I said, you can test directly out the front of the machine between the 2 red wires, but you can also test where they're coming off of the fuse and the relay going out to the front of the machine, which is on the back side of these components. So you've got one lead that goes out the front of the machine. It comes directly off the back side of this fuse holder, and then you've got another red lead that comes off the back right corner of the solid state relay. All right, so now we'll get ready to test all the components. We'll start by testing the voltage output from the machine. This is the part of the video where it'll really become cut and dry what may be causing your hose heat issue. And the first test we're gonna do are those 2 red wires off the back of the fuse and the relay. Remember that you wanna perform those tests to determine how much voltage you're getting out of your machine. If you didn't have any amps when you tested your amperage draw, then you obviously want to test to make sure that you have voltage coming out of the machine, or if your amp draw was low, you want to test and see how much voltage you have coming out of the machine. So to do this test, it would be kind of hard to show you inside a machine, so we actually have a model set up that we're going to go to, and it's set up just like the inside of your machine is, but it'll be easier for me to show where you want to perform all these tests. But remember, when you're doing this test, when it comes time to actually test the voltage AC, which will be this, it'll say VAC, or have a V with a squiggly line, you want to turn on your hose heat breaker and set the controller to call for heat again. So we'll show you to do that, but obviously with our model not being hooked up in a machine, you just will want to remember to obviously turn that on before you perform the test. All right, here we have a model set up just like the hose heat system on the bottom of a Boss machine. We're just using a smaller transformer right here. This transformer is good for up to 150 feet of ball spray hose. The highest voltage option on it is actually 50 volts, while the transformer that's in most Boss machines is good for 400 feet of hose, and the highest voltage option on those transformers is 120 volts. I've decided to switch to the Milwaukee multimeter just so that you can see the readout a little better. So we're going to switch away from this Fluke. Both of those are really good. Also the Kleins are really good. You just want to make sure you have a multimeter that works and that you know how to use, obviously. So the first thing you want to do is turn on your hose heat on your Boss machine and set the control to where it's calling for heat, where the green light is blinking. Go ahead and do that now on our setup. All right, so now that we've got our hose heat turned on and the controller set to calling for heat, remember the first thing we want to test is the voltage output directly out the front of the machine. And you can test that directly off the back side of the fuse in the relay. So you want to find the 2 red welding wires that go out the front of the machine, and you'll want to perform a test right here to determine what voltage you're currently getting. Now we have the 20 volt option connected on our machine, and we have the 20 volt option connected here on the smaller transformer also. So you can see we're getting roughly 20.8, 20.1 volts right here, and that just means we're getting a little more than 240 volts into the machine right now. So because we have a little more than 240, we got a little more than 20. So our voltage is perfect. Now, if you were to perform this test, and let's say that you had the 50 volt lead hooked up, and you were to test directly out the machine, and you had 50 volts or 51 volts or 48 volts, something that was really solid, then you would know, okay, my machine is doing exactly what it's supposed to do. I talked to so many people who are convinced that they have an issue with their machine because they've already looked through their hose and they can't find anything on their hose that would indicate a broken connection or something wrong with the hose. But you can be 100% positive that if you test power directly out of your machine and you've got what you're supposed to be getting based on getting 240 volts into the transformer, that your issue is not with your machine side of things, and you can focus on the hose at that point. And remember, if you've got less than what you have connected coming out, so let's say for instance you only had 15 volts right here, well most likely that means that you don't have a full 240 volts coming in on this side of the transformer. You might have like 230 or 220 or 210, and in some cases some people only have 160, and that's going to cause you to have low voltage. So if you were to test right here, and let's say we've got the 20 volt lead hooked up, let's say we were only getting 15 or so, then the next test we would want to do is we want to go back to before the fuse in the relay, so directly out of the transformer, so between the 2 wires directly out of the transformer. We'd want to test right here on the 0 volt lead on the relay, and right here on the 20 volt lead on the fuse holder. So at this point we're testing directly out of the transformer before the power even gets to the fuse in the relay. And if you still only had 15 volts right here, then you would know, okay, most likely I've got less than 240 coming in my transformer. So the next place that you actually want to perform tests are in the top of your machine. In the top control box, you'd want to test between the top 2 posts on the hose heat switch. And then if you had less than 240 there, then almost guaranteed you're going to have less at the main breaker where the incoming power is coming into your machine. So then you'd also want to test your main power and confirm that you have less than 240, and that's most likely going to be why you have 15 volts going out to your hose and why your hose isn't as heating as well as it should. Now let's say for instance that you went to test directly out the machine and you didn't have any voltage at all. Well, that could be caused by 3 things most likely. One would be if you have a defective relay, or if you have a defective fuse or a blown fuse, or if you weren't getting any incoming power from your machine at all, or to your machine at all, then obviously you would not have any voltage going into your transformer and on the other side of the transformer either. So those are the 3 different things. So in that instance, what you're looking to find is at what point do you no longer have power. And so testing right here, directly out of the front of the machine, we know, all right, we have no power. Obviously it shows we have power right now, but we'll just act like it didn't. If we didn't have power right here, then what I want to do is I always want to go to before the fuse in the relay. I want to eliminate the fuse in the relay and just test directly out of the transformer and see if I still have no power. And most of the time you probably will have power, because obviously your incoming power is probably fine and your transformer either works or it doesn't. So let's say you test right here directly out of the transformer between the 0 volt lead and the 20 volt lead in our example, and you have 20 volts. But then you go to after the fuse and the relay, and you no longer have that 20 volts, you have no volts. Well, then most likely either my fuse or my relay is bad, and we've got to isolate both of those to find exactly where the problem is. So to test the relay, we'll start with testing the relay. What we want to do is we want to isolate the relay to where it's the only thing that we're testing. So we're going to test after the relay on the relay side, but we're going to test before the fuse on the fuse side. So right here we're testing directly out the transformer on the 20 volt lead before it goes into the fuse, but we're testing after the relay like we would be going out the machine. So we're still testing between the two sides, we're just testing at different points. And we should still have 20 volts in this scenario. Now, obviously we still have 20 volts. And let's say we did this test and we still had 20 volts right here for the relay. Then we would know, okay, our relay is working properly. We want to isolate the fuse and see if the fuse is the problem. So in that scenario, you would move your tester to after the fuse in the system, on that side of the system. And then you would move your probe on the relay to before the relay. And as you can see, you should still have 20 volts if everything's working properly. And so right now we're testing after the fuse but before the relay. And in this scenario, we're testing before the fuse but after the relay. And most of the time, one of those is going to be defective and you're not going to have voltage, and you'll know which one it is based on which one you're testing after. Now, something to remember is you should always have 20 volts between the two sides no matter what point of the system you test. So for instance, all the way down at the gun end of the hose where the two sides loop together to complete the circuit, you should still have 20 volts. Now, it may not be a full 20 volts that far out. It may only be 19 or 18.5 or something, but you should still have 20 between the two sides. And likewise, whether you're testing directly out the transformer or whether you're testing after the fuse and the relay, or let's say we were testing directly out the front of the machine where our welding wire is spliced to our hose, or if we were testing after our first section of hose, or like I said, down at the end of the hose on the gun end of the hose, you should still have roughly 20 volts between the two sides. And likewise, let's say we were to test right here before the fuse directly out of the transformer on the 20 volt wire, and then let's say we were to follow this red wire on the relay side of things out the front of the machine to right where it connects to the hose. You should be able to test between these two sides and still have 20 volts. And likewise, if we were to swap and we were to test before the relay and then test after the fuse out somewhere down the length of the hose, you should still have 20 volts. So you should always have 20 volts between the two sides. And once again, that's based on having 240 volts coming into the transformer. And so if you have a different voltage option hooked up, the 20 volts is for 50 feet of low voltage boss hose, 50 feet of 3/8 inch hose. You could have the 35 hooked up if you have a 100 foot hose. You could have the 50 volt wire hooked up if you have a 150, and you have the 64 volt wire hooked up for a 200 foot hose. And in that scenario, you would have 64 volts between these two wires directly out of the transformer. Obviously, we're using the 20. And these are capped off right now, but if I were to go ahead and take my probe and leave it on the 0, and take my other probe and put it, let's say this one's the 50 volt wire, and I were to test between the two, I would have 50 volts, because it's always between the two options that you are testing is going to be the amount of voltage that you have coming out of the transformer. For a little more information about how to understand how the transformer works and the different options that are coming out and how to visually kind of see what's happening, we'll have some other video that you can watch that explains exactly what's going on with the transformer. All right, so let's say that you've tested voltage out of the machine and your voltage is almost perfect. You know that your machine's operating properly, you're getting exactly what you're supposed to get out of it. Then obviously, most likely, if you're not drawing any amps or you're drawing low amps, your problem's going to be somewhere along the length of your hose now. So if you suspect the problem's in the hose, the first thing you'll want to test is down at the gun end of the hose where the two sides loop together to complete the circuit. This end is out towards the gun, so it's taking the most abuse and it's prone to potentially come apart. Now, I've got an example hose right here, and in this scenario, obviously our hose heat is not on right now, obviously, so there's no power live to this. But in this scenario, Normally, your two sides, this would be taped up with some cloth fiberglass tape, and it would be folded back, laying against the hose somewhere. So you would want to actually dig into it, cut it open, expose it, and make sure that these two have not come disconnected from one another. And that's the first place to check. I would always just check that first, just to make sure that that's not where your issue is. The other areas to check first would be at any connection. So at each section of hose where it connects to another joint of hose, obviously instead of looping back to each side, this section just goes to the next section of hose, and this side just goes to the next section of hose. And so you'd want to check at each of those connections to make sure the welding wire at those connections does not come loose. So those would be the first two places that I would check, in addition to maybe checking at your machine. It's highly unlikely that those have come loose. But another thing to note is that these welding wires, they actually solder to flat copper a little further down the hose. So each section of the hose has welding wire on one end, solders the flat copper, and at the end of that section, the welding wire, or the flat copper, solders back to welding wire. And so that's the same for each section of hose. So you would want to investigate whether or not that has come loose as well. But if you look and see, and you can tell, okay, gun into the hose, everything's connected, there's no loose connection. You've checked, right now we only have one section of hose hooked up, but if you had multiple sections, you've checked at each joint to make sure that everything's working properly. Then the next thing that you'd want to do to identify which side, whether it's the A or B side that your brake is on, would be to test continuity end to end. And so in order to test continuity end to end, you would disconnect your butt splice at the gun end of the hose where it loops back to itself to complete the circuit. The first thing I'd want to do is I'd want to go out to my gun end of the hose, disconnect the welding wire from where it loops back to itself, and then you want to drag your gun end of your hose back to your machine and lay them side by side, each end. Now obviously you would also want to disconnect your welding wire from the machine so that those ends are exposed also. And then you would simply test end to end on each side for continuity. So you would take the B side welding wire, that once it's exposed, you'd put one probe there, and then you'd take your other probe and you would put it on the B side on your gun end of your hose, and you would test end to end for continuity. And most multimeters, that's going to make a beep or a sound. Some of them might just be a light, but that's what you're looking for. And then you would do the same thing end to end for the A side. So you would get your A side welding wire on each end of the hose, and you would put one probe on each and test for continuity. And obviously whichever side does not have continuity indicates which side your brake is on. Now at that point you still have to search for it, and you still have to work your way down the hose. So what I would suggest is, if you have multiple sections of hose, you would just go ahead halfway down the hose, or maybe after the first section, and do the same test, and pull that section back to where it's side by side with your machine into the hose, and just test that first section or the second section or wherever the midway point is. If you have one section of hose, continuous section of hose, then you're going to have to go ahead and find the midway point of the hose, remove the scuff jacket, and then you're going to want to nick some of the blue or red wrap. Further down the hose might actually be black on both sides, so you might have to actually nick away some of the tape on both sides to determine, once again, which side is my A and which side is my B. Then you would essentially test with one probe on that exposed spot midway down the hose back to that same side on your machine end of the hose. Now obviously you might have to test both sides to figure out which one is actually the A and which one is actually the B once you're further in the hose and you can't tell. But once you've done that, then you can essentially have a midway point to test from. And obviously if you have continuity from the machine to that midway point, when you didn't have continuity before, then you know that my brake is somewhere in the second half of the hose. If you don't have continuity still within that first half of the hose, then you know, okay, my brake is somewhere in the first half of the hose. And then you just work your way back from each midpoint, either from that point down to the end of the hose or from that point back to the machine, to try and determine exactly where the brake is. You could perform this test from the gun end back to the machine, not have continuity on your B side. Then let's say you go to the midway point and you test and you still don't have continuity on that first half of the hose. Well, then let's say you go a quarter of the way from the machine down the hose and you test there and you still don't have continuity. Then I would recommend coming back 10 feet and just trying within the first 10 feet and seeing if you have continuity at that point. And if you don't, then obviously it's somewhere within the first 10 feet of the hose, but I would work my way back to where the solder is from the welding wire to the copper, and just make sure that that hasn't pulled loose for any reason. And the same thing for the gun end of the hose. If you're testing all the way out at the gun end, you don't have continuity, but you've tested pretty much all the way down to that gun and you do have continuity up until that point, then I would go ahead and try and look in there and make sure that hasn't come loose. One thing to note about this, whether you're just connecting side to side down at the gun end of the hose to complete the circuit, or whether you're connecting from one section to the next section on each side, whether you have one of these butt splices is going to get very hot, and you want to go ahead and wrap that in some fiberglass cloth tape and then wrap that in some electrical tape. And typically you want to fold those back away from the fittings once you have once you have it connected, obviously on this side, and then you would have your next section of hose connected right here. You would want to wrap up that excess and tuck it away from a fitting, just so there's no metal to metal contact. But before you tuck it against the hose, you want to make sure that this is insulated really well so that it does not actually melt the hose because it gets so hot. So you want to do that on each side, at each section, each joint. And then obviously at the gun end of the hose, the two pieces go together, and you do the same thing. You fold back, pick a side for it to fold back to, and just wrap it up, tape it up really well. This is where the excess TSU is. So you want to work your way back and locate right here. And then obviously if it were pulled out, it would no longer be in here, but this is where the bare ends of your TSU are located. So this is twisted together and it reads temperature when the two strands are touching. And it's tucked inside the insulation and then taped up very well. But if for some reason this is pulled out and these two strands come apart, your controller will likely read input fail. Located. Or if it just comes untucked and is laying loose inside the scuff assembly, so that's no longer tucked in against the hose, it's going to be reading more of an ambient temperature, more of an air temperature. And your controller does not know that the hose is already up to temperature, and it's continuing to send power to the hose and will eventually overheat it. So you just want to make sure that this is not untucked. And if it is, you want to make sure that the strands are twisted together well and that the end is inserted back into the hose and secured to the hose very well.
We hope you found this video helpful. Please like and subscribe so that you don't miss out on the next video getting the most from your Boss equipment. Leave any questions you have in the comments below, and we'll see you in the next one.